Hey everyone, it's Mark. Welcome back. Long time no see. The last video I put up was about 6 months ago, I think. I left one of my car videos hanging saying, hey, if depending how the weather goes, it might be it until spring. The next day it snowed. Happy Halloween. I haven't been doing much, and now quarantine, stuck in the house. So I've been working on this for the last month. Now it's like the worst part of the quarantine, I guess. We're not supposed to leave the house. So luckily I got all the parts I needed and it's together. So what we have here is a CNC router or CNC mill, whatever you want to call it. I didn't film the process of making it because I didn't know what I was doing. I was just basically had a pile of scrap parts and a shop full of miscellaneous garbage. And other than a circuit board and a spindle and another circuit board and a power supply, you know, just I don't know, 150 bucks worth of stuff. Basically everything else was stuff I had here. I'm just gonna do a quick overview of what I did just to show you what I put together. I say quick, but I know how these things usually turn out. And then right now it's just sitting here. It's not put together, obviously, because I put it together in the house. Now I'm gonna actually start making stuff with it, and my wife's tolerance for metal shavings on the dining room floor is pretty low, like you might imagine. Since it's coming out here, I can start actually doing some serious stuff like resurfacing the top because I'll show you in a minute, but I found a real low spot and it was giving me some issues with my test cuts. So let me show you what I did. So here she is. What we've got here is a CNC router with an 8x8 table. I'll just start from the table and work my way away from it. I've got 1-inch grid with 1032 holes drilled and tapped for hold downs. All I'm using for hold downs, just these, I think these were from a bag of hardware to put a countertop together. I'm not sure, but anyway, they've been working as hold downs, so just put in a screw. So that's that, that's 1/2-inch aluminum. That is leftover scrap from the sign I made for the tattoo shop a couple years ago. It is attached to 4 linear bearings and rails, which are recycled from a machine at work. But every once in a while we have to replace the lead screw or the rails or the bearings, and it's maybe not good enough for doing precise dispensing of reagents to synthesize DNA for a hospital or a university, but it's good enough for an idiot to tinker with in his garage, so I brought him home and I made him work. Limit switches, just some random micro switches. Plate I made to mount it. I had to buy a custom belt. The stepper motors, I used the same ones for all of them. That's again from another piece of equipment that stopped working for professional purposes, but the motor parts still seem to be fine, so I've kind of got a pile of those that I've dug out of the garbage. The lead screw, actually much of this assembly here is from a machine at work. Oh, and the base, this was a piece of 1/8-inch aluminum that I bent up for a project like 15 years ago. It was going to be an electronics project box. It never materialized, and it was just about perfect for this. More 1/2-inch aluminum from the sign. This is just 2 rails, just extruded aluminum angles that I had laying around. This is an identical lead screw, identical bearing. Back here's where I have my limit switches. Just as that moves along, it just runs into the end. More of the same motors. Again, had to get another custom size belt. This belt happened to be a size that we use at work a lot and we're always replacing. So, you know, I can bring home ones that are replaced for maintenance, save them from the garbage, and they'll be good enough for me forever. These rails and bearings are from a different machine that we had parted out. You can tell I cut the ends. These were longer, and I cut one to put here, and then cut another one for the Z rails, which identical bearings. They're just a little bit smaller, lower profile than the ones I use down here, so that's why I chose those. I figured the farther in I could keep all this, the better for rigidity. This angle bracket, this is from something I dug out of the garbage at work. It held this for held the motor for a different use. I just cut it down and made it work. Similar story here. This is from something at work I dug out of the garbage. Cut it down. This plate right here that holds the motor, I just made that. More 1/2-inch aluminum. Another micro switch here for the Z upper limit. I don't have a Z lower limit switch. At the time I didn't mount one just because I didn't know where to put it, and I figured I'd figure it out later, but I've since realized that a bottom limit switch is kind of pointless because by the time that clicks, I've already crashed it. So, oh, and I have limit switches are each working as limits and homes, and I can get into that in a little bit and explain how I did that. The spindle just came as a kit. This is just standard Chinese stuff. I ordered it in a kit with a driver and a power supply and a selection of collets. See, they're kind of laying around here. Got a full range of ER11 collets. Oh, and that bracket came with it as well. And I think that's about everything. This lead screw is a different lead screw. It's from the same piece of equipment that this mount and these motors came from. Again, it gets worn out to a point that it's not good for dispensing, you know, amounts of liquid down to a microliter, but it's good enough for my purposes. That's mostly the hardware part of it. Before anyone asks, no, I don't have any plans. I don't have any drawings. I just started winging it. I had these rails, I had this thing, I just started screwing it all together and just kind of built up from there. I landed where I landed. Okay, now we're down in the cabinet. I didn't mention the cabinet before. This came from my wife's hair salon. It used to be her station where she kept her tools and stuff for cutting hair, and now it's here because she got a new one at work. And it's like, oh, stainless top, wheels, cabinet, drawer, perfect. So here's what's inside. Again, this isn't together, but I'm going to put it together to show you all the connections and everything. Got a 24 volt power supply. This again from the garbage at work. It fried a MOSFET, threw it away and just replaced it because it's cheaper than worrying about if we can fix it and then having a problem at work could cost us, you know, hundreds or thousands of dollars in failed product. Whereas here, I don't really care. So I brought it home, I replaced a MOSFET and a fuse and it works fine. But, you know, power supplies are cheap. This is a 48 volt power supply. This came with the spindle. This is a Meanwell. This is a Men's W. Obviously a rip-off Meanwell, but you know, switching power supply, probably basically a clone. It works fine. Here's my 3-axis breakout board and opto isolator. These are everywhere. You know, the usual scumbags from China. I think this was about 50 or 60 bucks. It's got the Toshiba 6060 chips. Is that the number? I'll make a correction here if that was wrong. But there's two ones. There's like a something 50 and a 60. But anyway, this is the bigger one. It'll handle a little more current. This came with the spindle. This is just the motor driver. This can handle 2 different ways of modulating the speed of the spindle. I'm right now using the knob speed. I just have a knob hooked here. And then I have the board interrupting that signal so that I can switch the spindle on and off. I just have to adjust the speed manually. This does accept a 0 to 10 volt DC variable input that it converts to pulse wave modulation to control the spindle. I couldn't get it to work. No matter what I did, I would try to turn the spindle all the way up, all the way down, and even on off, it would just turn at a very slow RPM. I don't know what was going on. I finally got to a point where I didn't really care that much anyway, because I just have a knob. I'm not doing anything fancy enough that I'm going to be like changing tools and then have to change speeds without stopping the program and manually changing things anyway. I ran just a crummy little power panel here. I just have a switch to turn on each power supply. So I can have the 24 on and be manipulating things, setting things up, tramming things in, and not have to have the spindle power supply just sitting here, just creating heat and wasting energy if it's not going to be doing anything. Like I said, the spindle speed, I got a button for e-stop. It's not ideal. It probably, you know, usually you see a big red mushroom button up on top. I didn't have one. I just grabbed a random push button switch I had and put it here. To be honest, I've rarely used it. I just get my finger on the button if I'm going to start a program and make sure it's just not going to do something crazy. And as soon as I'm confident, like, okay, no, it's running like I think, I can kind of relax. I'm not really working with enough power here anyway where I'm going to like injure myself too bad. Let me get the PC. Here's the brains of the outfit. This is just an old Dell Dimension. Got that from the basement. I think a lot of people like me, if you have lived a normal adult life in these eras, you've had a lot of different computers over the years. And if you're like me and you hate to get rid of things, they sort of just follow you around from house to house. That was the case with this. This was actually my wife's computer before we got together, and obviously we share one now. So this wasn't being used, so I wiped it, reinstalled Windows XP. This will never be online, so I sort of went into the software and did a little bit of hacking and manipulating to make it not keep asking me to update things, not keep asking me to register, not installing antivirus, you know, just took off Internet Explorer, took off Messenger, took off all that unnecessary garbage, and it's just for this machine. I can bring files on a jump drive. I can, you know, make what I need on the main computer in the house, and then bring it out here, plug it in, drag and drop, done. So what I just hooked up is power. I've got a power out for the monitor. This is the serial cable that comes up here to this board, and that's really what you're looking for when you're trying to find a computer to do this job. You want one with a serial port with a 25 pin DB style. Yeah, and this isn't ideal being down here since it has to fit sideways. It's kind of hard to reach the power button. Then when I bring my jump drive, I have to turn around and back. I am going to mount a USB port up here so I can plug the jump drive in there at least. I don't think it's worth the trouble to move the power button for as rarely as I'm having to turn it on and off. I'll get some wires running here. This is everything I just pulled in from the back. There's my e-stop. It is a really crummy switch. I hope I don't ever actually need this thing to save my life. Okay, and this small DB9 connector, this connects to all the inputs, which is, in this case anyway, X, Y, and a Z limit switch, an e-stop. I have an extra one on here that I'm gonna hook up for an automatic Z find probe thing. I haven't quite got that working yet, so I'm still setting Z manually with mixed results. But that just plugs in there. This has dip switches you can set for different amounts of micro stepping and also current limiting to the motors. I have it set that I'm limiting to like 1 point something amps to the motors. They're 2 amp motors. It hasn't been an issue yet. I had the micro stepping all the way up to 16 steps. I backed it off to 8 just because I seem to be having some issues at that high a rate. I don't know if it was related to that, but it's gone away since I did that, so I might have been getting some interference by doubling the electrical pulses per second. It might have created some weird interference. I'm not sure. I'm new to all this. Okay, this is just the wire coming from the spindle motor. That just goes in here. I'm not gonna make you watch me do that. These are the wires going to the motors. Again, maybe this is part of my problem with interference. I don't have any kind of shielding or ferrite beads on here or anything. Those just plug in there. This is the spindle switch. This is actually rated to switch off a fair amount. It might even handle turning this 48 volt DC on and off. It's kind of right on the edge of what it says it can handle. As it is right now, I'm just switching a very tiny amount of power just going to the speed switch. As I said before, just turning it on and off. I'm not doing anything crazy there. But if I didn't have a speed control and I was just gonna have the spindle always on or always off, I would have to switch it, the power coming out of this. This might be pushing it. I might have to do a relay, but in this case I made it work since this came with the motor. I was able to use it. And I think that's all the connections down here. So I'm gonna hook that up off camera and then we'll go back up to the top. Okay, ready to turn it on. See if it made the journey to the garage with no damage. All right, and I set it to automatically load up Mach 3 because I'm always going to be starting with Mach 3 on this. I just select the profile that I called Mini Mill for this, and that has all the settings already programmed in. And there's Mach 3. So obviously right now it's in an error mode because I don't have power on. So let's do that. Now when I hit reset, you'll probably hear a clunk. That'll be the steppers getting power. There you go. And we have a mill. There's a few things that seem really simple, and I think because they seemed so simple, it was hard to find the answers to these questions. I mean, sometimes the harder questions are the easier ones to find answers to because everybody has the same ones and everybody's talking about it. But the really simple ones, I think people with some sort of background in CNC just know it. And I had really no background in any kind of CNC machining whatsoever. I have a manual machining background, completely self-taught, and then I have electronics background from school, so putting those together was a new thing. One of the things in Mach 3 that I had trouble with at first was this button. I couldn't understand, you click this button and all your values change. It said, okay, machine coordinates. Well, isn't everything in the machine coordinate? What this is, when this is red, those are the coordinates of just the machine. Like, it doesn't care what's here. You could have this tiny little workpiece here or a huge workpiece here. It just wants to know, you know, this is 0, this all the way up is 0, in this case anyway. That's what it wants to know. You click that off, the opposite of machine coordinates in this case is, you know, the workpiece coordinates. I don't know, I think they probably have a better name for it. And that would be, let's say you had a little square piece of metal on here. You don't care that 0, 0 is down here on your table. You want 0, 0 to be up here on your workpiece, because if your workpiece is here, you're never going to be machining over here. So that's the difference here. To initialize this, I want to go to machine coordinates first, and then reference all home, and it will go up until it hits a click, come down a little bit, go over, click, go back, click, or I'm not sure if it's that order. And then everything here is going to turn green. And that means I'm happy, I know I'm home, I know I'm at 0, 0, and everything's good to go. So I'm going to do that now. There you go, they're all green. We're at all zeros. Now we go to the work coordinates. You'll see I have plus 3.3692, I'm in inches, by the way, on the vertical. And that's because I still have Z set up 0 at the tabletop from last night when I was messing around with this. I mean, I can change that right now. And now this is 0 for the work and for the machine. To set that back, I've got hotkeys standard are the arrows for X and Y, and page up, page down for the Z. So I can just page down and get back down to like -3 something. We'll say that that's touching off. Then I can 0 it, go back up, and you can see now I'm back in the like +3 range. So that's how that works. Another thing I did that was kind of really sped things up for, you know, just like hand manipulating things with the arrow keys is if you go into hotkeys, I changed my Y positive and negative so that instead of pushing the arrow forward, normally this would come forward and that's intuitive, but I have this part that moves, not the spindle. So it was really confusing to push the forward arrow to move this back and vice versa. So I switched that around backwards just to make it easier for me. But nothing else changed, it's just the keys I push to move it. So now forward moves forward, backwards moves backwards. And really that was the stuff that really confused me, just those few things that I just went over. The rest of it pretty intuitive. Feed rate gets a little weird, but I'm starting to figure out that you just sort of learn your machine, you learn a good number for feed rates based on what you're doing. It seems like I seem to be somewhere between like 50 and 150. Obviously metric is going to be wildly different, but that's just what I found. Let me pull you up here to show you my project for right now. Okay, so here's the work surface. Now, as I showed you, the buttons forward now brings it forward. So I put in this just a little V-bit for engraving. What I really want to do with this is cut circuit boards. So I got some little V-bits that I think would be good for that. And I just did a light pass based on about what I thought the top was, and you can see a very pronounced low spot right here, which is what I figured. I clamped down a few pieces of aluminum, was doing some practice, and I was finding that it would get deeper as I moved over this way and get lighter as I came down, so that explains it. So I wrote a script. I'm also teaching myself G-code, which is much easier than I expected. So this is one I wrote, and you can see on the tool path, it's very fine. What it's doing is it's just coming up the table 1/10 of an inch at a time and going back and forth very slowly. I don't know if this is going to work, but the ultimate goal is to take off just enough off this entire table to get it flat and try to have a good surface finish. I don't have the best bit. I was digging around in my junk. Most of my end mills came from like lots at auctions. This is totally the wrong bit, 5 flute, but it's carbide. It's 1/4 inch, which is the largest tool I can fit in my collet set. Brand new and it's sharp, so I'm gonna make it work. Okay, I got my bit in here. I think what I'm gonna do is touch off on this low spot. I've got this program to be moving pretty slowly. I'm only going up 1/10 of an inch each time. So across an 8-inch table, that's about 80 passes back and forth. So this might take a little while. And one thing I'm gonna do before I start, I'm gonna take out these screws to hold the top in. They're flathead screws. I'm gonna countersink them just a little bit deeper, because as it is right now, I'm gonna be taking off the tops of the screws. I'd rather not do that. Maybe I'll do that first off camera before I touch off. All right, I just countersunk all the screws a little bit farther. Hopefully I won't hit them. If I do, it's carbide versus stainless steel, so I think I'll be okay. I'm just gonna re-reference everything home since I've been screwing around with it. We'll touch off. Oh, and I have soft limits set up. So as I get closer to, roughly what the bottom is. We don't know what the bottom is because every time you change the tool, it changes. But I have soft limits set up so I don't just go crashing into things. So you'll hear it step down, and it just sounds like a note descending. That's the stepper motor speed slowing down as it gets close to what it thinks is the bottom. Okay, I am not there yet. Okay, there I'm starting to hit. I really don't want to run this program twice because it's going to take a while, but I guess if I have to, I have to. I think that's going to work. I'm going to call that my 0. Okay, and the way my program is set up, if I can remember all this right, M3 will turn on the spindle, and there's like 2 or 3 or 3 and 4 or something like that is counterclockwise, clockwise. None of that's set up in mine, so I don't know which one that is. F100, that's the feed rate. If I start going and decide that's too fast or too slow, you can adjust it here up and down on the fly without messing up anything here. I suspect, if anything, that might be a little bit fast. And if that's the case, I can just click the down arrows. It'll just go down until it's a feed rate you like. So that's a nice touch. I could do the same thing with the spindle speed if it were set up through here, but instead I just have that knob. So then I'm gonna rapid to the Z to 100 thousandths above the table. So that's going to be pretty low, but there's no fixtures, no clamps, nothing else to hit for this script. So I just, in that case, just wherever I am on the table, just make sure you get up enough that you can move over. Like where I was just touching off. If I forgot and started running the program, instead of just dragging over, it would lift up a little bit first. And then we're going to rapid, G00 is rapid over to 00. And then G01, that's the slower feed rate. It's going to drop Z down to 0. And then we got 8, which means all the way over. And then 0.1 goes up 1/10 of an inch, then all the way to 0. And then up 1/10 of an inch, and all the way to 8. And up 1/10 of an inch, and all the way to 0. And it's going to do that about 80 times. And then at the very end, I have it, you can see it here represented by this dotted line. It will, when it gets to the end, pick back up to that 1/10 of an inch above the table and just wrap it back to home and then turn the spindle off. Let me regenerate this. Yeah, I had some weird stuff going on there. I just wanted to make sure that wasn't in my program. I haven't run this program yet. I wrote this last night at about, 4 a.m. this morning, I guess. Work's got me on second shift right now, or third shift, so it's the weekend and I'm trying not to stray too far from third shift. So there you can see each one of those lines represents 1/10 of an inch step over. This is always the nerve-wracking part. I'm going to run it and see what happens. I'll have my finger on the e-stop. Well, that almost worked. Oh, that's my problem. Okay. Back to start and finger on the e-stop. And what I hit. I hit a limit switch. Apparently it didn't like going over to 0. Okay, let me figure this out. Okay, so I rehomed all the positions. I bumped it over just one little bump of the switch and then re-zeroed it. So now it's just, it won't get as close to hitting that limit switch. Normally this wouldn't be a problem. on a workpiece in the middle here, but since I'm trying to get right up to the edge, just the way the machine is designed, I can get quite a bit past over here, but I just have trouble getting right up to that edge. So I'm gonna try this again. Yeah, I'm gonna slow that way down. Well, it just paused on me again, about 2 inches from the end. I hit the limit switch again. I keep hitting limits, like I'm not hitting them for a while and then I bump into it, which leads me to believe that I'm either losing steps electrically or physically through the belt or a loose pulley or something. I'm not sure. I mean, it's not much, but it doesn't take much. So that's something I'm gonna have to continue to investigate. In the meantime, you can see some ugly lines right here. That's because as I was going up, I was getting deeper and deeper, and I was worried about getting too deep. So I bumped it up a little bit, and I think I'm actually gonna bump it up a little bit more. I think it's getting quite a bit taller in the back. So I'll go up a little bit more, finish off, let it take a little break, and then I'll come back and do another pass on everything. Hopefully at a higher feed rate, because God, this is taking forever. But it's looking so much better. I'm really impressed with the finish I'm getting with that 5-flute carbide bit. I just keep spraying a little bit of WD-40 on there to lubricate it. My motor's getting pretty hot again, so I'm gonna let it cool down, and I probably won't film any more of this. You get the idea. I'll just bring you back when I'm done. Well, as long as this doesn't screw up, this should be my final pass. I've done a few passes, had a few issues, ran into some limit switches, but I'll turn you around and show you what the final pass looks like. Alright, there you have it. I'm gonna clean that up off camera, but I just wanted to show, I noticed my line here gets wider and wider as you go back. So that means my table here is either isn't perfectly square or the rails aren't perfectly perpendicular to that. Not sure. Again, it doesn't really matter. But just something I noticed, which explains why the farther back I'd get, the more problems I would have with limit switches. A few final thoughts. First one, I hate that. That was where I had a code mishap and it just kind of went, that sucks, but whatever. I'm not going to remill the whole thing. A couple more passes just for that. Big final thoughts. A lot of things that I had thought about but never really got around to implementing, now I'm seeing as more of a priority. One of those being these limit switches. I didn't have heat shrink tubing over the ends. It did not take long for enough aluminum to pile up here to trigger the limit switches. So that's a thing I'm gonna have to worry about. Mouse pad should not be smooth fabric-y kind. It should be the hard plastic kind because chips are getting stuck in it. I really need a divider right here. I had planned on maybe putting a box around it. I'm not sure if that's necessary, but at least I'm gonna get a piece of plexiglass and just like put a divider here just to keep the chips from landing on the mouse pad and the mouse and the display and everything. The keyboard, I sort of plan on keeping it in here. I think I'm gonna go with that for now, but if I had a shield, I don't know if it'd be necessary. I could maybe just leave it up there. Kind of annoying because you pull it open just to make a minor adjustment and then you click go and then you forget, leave it open, you start getting chips in there anyway. So. Aside from that, that's all I can think of. I'm still figuring it out. Well, there you go. I hope you enjoyed that little journey in CNC machining from a newbie. I got a lot to learn. I've only had this thing working for a matter of days. I think I'm picking up pretty quick. It's not as intimidating as it looks to begin with. You know, you think, oh my God, how am I gonna get a machine to talk to a computer and then give the computer code that can make sense of? And it's really not too bad to figure out. There's a lot of help out there, a lot of forums. You just kind of have to like stumble your way through it and make some dumb mistakes, and that's how you learn. So I'm gonna wrap this one up. Expect there to be some actual projects using this in the near future. I want really, like the whole point of this was to be able to make circuit boards because I have a few projects I wanna make circuit boards for. So keep an eye on the channel and you'll see some things like that coming up hopefully. And if it ever warms up, I'll be working on the car again. So thanks for sticking out. Long 6-month gap with no videos, but glad you're back. Stay inside, don't cough on anyone. I'll catch you in the next one.